Alright, this video is on linear equations and creating linear equations from graphs. So we've learned and we've looked at the fact that y equals mx plus b is the main form, it's called slope-intercept form of a linear equation. So we're going to go through this a little bit more detailed. In this equation, y is the independent variable. It can be many different numbers. That's kind of what variable means. It varies. It can be anything depending on what x is. And that's the kind of the thing. It's dependent on x. Okay, so in an example, if we're talking about the real world, like if you're riding a bike, your distance depends on how long you've been riding. Or if you're selling magazines, how much money you've sold or you've made depends on how many magazines you've sold. M is the slope of the line. It's always a number. We'll put in a number for that M, so that will be replaced. Sometimes it's a fraction, sometimes it's a whole number, but you can always think of it as a fraction. It's either going to be positive or negative. If it's positive, your line will be going up. If it's negative, your line will be going down. It's calculated by finding the rise and the run. So when we're looking at a graph, we'll be talking about, if we see a line, we'll be talking about how much does that line go up and how much does it go over. So the slope is kind of like this little triangle on a line. This is our rise and this is our run. That would be a positive slope. If we're talking about a negative slope, then just our rise is negative. We rise negative and we run. We always run right. Always run right. If you've seen Slope Dude always skis to the right. Okay, that's also called the change in y. So the rise is the change in y. The run is the change in x. Okay, and this slope is constant. It's our constant rate of change. So that's a little bit about the slope. The x is the independent variable. So like when you're biking, time would be the independent variable. It doesn't depend on anything. It's independent. Magazines sold would be the independent variable if we're talking about that and how much money you're going to make. Again, this is a variable, so it can vary. It can be many different numbers. And then finally, b is the y-intercept. It's where the line crosses the y-axis. It can be many different numbers. We'll put in a number for it. It could be negative if it's down here. It can be positive. It's just one point. And it's just the y. It's the y coordinate when x is 0. So it's always going to be 0, comma, some y is going to be our y-intercept, and we call that b. So that's a little bit about the equations in general. Let's do some practicing. If we were to graph some equations, we start by identifying the slope and y-intercept. So our slope here is 3/2, and our y-intercept is 2. So we start by, well, and if I want to be exact, our y-intercept is 0, comma 2. We start by plotting the y-intercept. So we go to 0, comma 2, and we make a point. And then we use the slope to calculate the rise and the run. Okay, so we're going to use this slope. This is our rise over our run. So we're going to go up 3 over 2. Up 3 over 2. And if I want to go backwards, I just do the opposite so that my line keeps a pattern. I check myself by saying, okay, this is a positive slope, so my line should be positive. And then I draw a line through that, making sure I have arrows on each side of my line. All right? Here, if we graph, we need to identify slope. My slope is 2. If I want to write that as a fraction, it's 2 over 1. Okay, any whole number is 2 over 1. My y-intercept here is going to be 0, comma, negative 5. So we're going to start in the negative. So 1, 2, 3, 4, 5. And then my slope is 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And I can draw my line with arrows. All right, connecting the dots. Those arrows tell us that it goes all the way through. That line goes on forever. Okay, here again I'm going to identify my slope as 1/3. my y-intercept is going to be 0, 4, or negative 1/3, excuse me. So I'm going to start at 1, 2, 3, 4. I'm going to go down 1 over 3, down 1 over 3, down 1 over 3, and again I can make my line arrows on both sides saying that my line goes on forever. So those are just a couple of examples. Why don't you try this one on a piece of graph paper? Try graphing that one. And maybe try graphing this one too. We'll see what those look like just for practice. Okay? And here's the answers.